Density Lab number 1. So I started by filling up my jar about 2/3 of the way with vegetable oil. And then I filled it the rest of the way up with some water. So there I am filling it up. And as you can tell, the water went to the bottom and the oil went to the top because of the density difference. Oil is a lot less dense than water. So I added some food coloring, and I realized that that was the only color that I had. So I went to the store after this because I realized that I didn't have any other colors. So I added 2 of the pink. And I ended up testing all of them. None of them worked. So I went back to the pink. I added a little bit more. And it was interesting to see how, at first, when going through the oil, the food coloring didn't mix. It just sat in a drop form. So I got my Alka-Seltzer tablets. And once it broke free to the water, it started mixing in. There it is fizzing. And it was really cool looking. And yeah. So I added another one after the fizzing slowed down, and it began to fizz a lot more. I was worried it was going to bubble over, but it's really cool. It was all mixing, which is interesting because of the chemical reaction caused, which allowed the 2 fluids with different densities to mix. And there it is, fizzing. Density Lab number 2. So I started out by measuring my honey. I measured out 1/4 a cup, and it was a little bit hard to pour, and that's because we learned this week that the viscosity of honey is a lot higher than other liquids, which is why the flow rate is much slower. So here I am trying to get all of the honey out, making sure I have 1/4 a cup. And I ended up adding like a tiny bit over 1/4 a cup because I knew that it would stick to the sides when I poured it. So then I got new food coloring since the other one was out. So here I am opening it. And I added 1 drop of red. And 1 drop of blue to make purple. So I stirred that all up until it became a purple color. And the purple color was kind of ugly. It was more like brown, just because honey is kind of gold as it is. So there I am mixing it. And then I almost accidentally added the dish soap early, which would have been bad. It would have messed up the density tower. So I almost added it, and then I realized that I needed to add the honey first. So I set down the dish soap, and I poured in the honey mixture. And as you can see, it flows very slowly. And I had to use my knife to get it out. So after that was added, I just washed off what had gotten on the counter, and I went to add the dish soap. And I was careful so that the 2 colors wouldn't mix. So I tilted it a little bit. And you can see it just went right on top. And you can kind of see the difference in the colors, which is really cool. Then I got out my measuring cup and I added green food dye to the water. Mixed that in so it turned green. And I carefully added that to the jar. And again, I tilted it so that it wouldn't mix. It did mix a little bit, but it rose to the top. So you can see the differences. It's hard to see when there's no light behind it, but I have a clip at the end where you can see. So I added the olive oil to the measuring cup, and I just mixed that in. and I was careful not to mix the colors again. Once I added the olive oil, you can really start to see the differences. And lastly, I added my rubbing alcohol. So I measured that out, and I added what I thought was red food coloring, but it was yellow. So I added that. It was kind of orange, and I added it to the top. And it's hard to see just because of the coloring of the food coloring, but they did separate, which is really cool. And it just, this jar and this experiment is proof that different densities act differently when mixed, and they flow on top of each other rather than all mixing together. So that's the density tower. So you can see all the separation. Viscosity lab. Because honey's harder to pour and I didn't have a ton of it, I put it in a smaller jar, but I made sure that the distance that the marble had to travel was the same on every liquid no matter what jar I used. So I got my timer out, and I started the timer when the marble hit the first line and stopped it once it went past the second line. So I repeated that about 3 times, and the average was about 3.5 to 4 seconds. And I marked it down on the paper. And then I got a different jar and marked about the same difference of distance on the other jar, and I filled it up with water, and then I started the timer, and I did that 3 times, and the average time was less than 1 second for the water. I repeated this with maple syrup, and I again did it 3 times. The average time was about 1 second for maple syrup. I then repeated the process with oil, and the oil was the second fastest next to water, which shows that it has the second lowest viscosity, and the marble traveled through it again less than 1 second. Non-Newtonian fluid lab. So I opened my cornstarch, and I added about a cup. It was kind of messy, so some of it spilled in there, but that was okay because I ended up needing to add more anyway, so I had to pour some back into the jar because I filled it up too much. So I scooped it back in. My dad had to come over and help, and it made a very big mess, but that's okay. So I added it to the jar, and then I filled up my cup, and I added half a cup of water. Well, first I added 2 drops of red food coloring because I wanted it to be pink. Then I filled up my measuring cup with half a cup of water, and I added this slowly. I didn't add it all at a time, and I mixed it up with my hands as I was doing it so that all of the cornstarch would get coated in the water. So I mixed it and made sure that everything was mixed and made sure that the food coloring was all mixed in. At first, it took a while for the food coloring to start showing up, but then it became pink. It was really cool to play with because it was a really strange texture. It was dry but also liquidous, which was interesting. Um, and the thing that makes this mixture a non-Newtonian fluid is that the physical properties aren't constant. So there's me trying to scroll on my computer. But so without force, it sits as a liquid and it flows, but when force is applied, it becomes thicker and acts almost as a solid. So here's me continuing to mix. This experiment was kind of a trial and error just because I had to add some more cornstarch, and then I had to add some more water. So I ended up using the cornstarch that was on the table when I realized that I needed more. I scooped some of that in, and I added it, and then I realized that I would need more water. And I kept mixing it. It started to get kind of dry, so that's when I realized that water was needed. So I filled up my cup and added a tiny bit more. After I did this, I realized that it was a little too wet, so again I added more cornstarch. And I continued trial and error until I got to the desired consistency. As you can tell, it was a little bit messy. I'm not the neatest when it comes to doing things in the kitchen. So there I am. I continued to play with it. You could see that I was playing with in my hands, and it was like a ball when I was adding force, and then once I stopped the force, it would drip through my fingers. Here's the final product. You can see as I hit it with the knife, it didn't splash at all, but it would flow when I moved the bowl around. And I could pick it up, and it would be like a ball, and as soon as I stopped applying force, it would slip right through my fingers, which is really interesting. Bernoulli's Principal Lab. So this was my favorite lab that I've done throughout this course. It was just really fun. So there I am playing around with the hair dryer and the ping pong ball, and I found it really hard to add two balls because, as you can tell, one of the balls would hit out, knock the other out of the low air pressure cavity made by the hair dryer. And so it was really fun to try that and play around with it. And I had really a lot of fun with that. The reason that this works is because the air dryer creates, again, a little bit of a tube that has low air pressure. And so the ball will continue to flow upwards until gravity pushes it back down. And as soon as the ball exits this low air pressure cavity, the ball will fall.